Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Stephen Feuerstein and I'm a PL/SQL developer just like you. This lesson is the first in my series on Say Goodbye to Hardcoding, one of the biggest problems we have in our software, hardcoding, and the initial lesson is Introduction and General Concepts. To get the most out of this webinar and this series of lessons, first of all, I assume that you have a working knowledge of PLSQL. If you've never used the language before, you might find this content challenging, though a session on hardcoding is probably pretty universal. I'm assuming an Oracle version of 10.2 or higher in terms of the features I'll be assuming you have access to. You also have access to all the demonstration code I'll be using in this lesson and all the other lessons in my series. Just go to my PL/SQL Obsession website, which is toadworld.com/sf. Download my demo zip file, and you'll have access in that zip to all of the scripts that I use to demonstrate techniques, provide reusable code, do performance analysis scripts. In addition, if you click on the Training, Seminars, and Presentations link, you'll zoom in on a page that contains all of the PowerPoints that I use in my presentations. Here's the website, PL/SQL Obsession. Lots of different utilities, so feel free to spend a lot of time looking around. Here's the demo zip link. Here's the training, seminars, and presentations. In addition, a couple of other websites I think you should know about. First, the PL/SQL Challenge. It's a daily quiz for PL/SQL developers with weekly, monthly, and quarterly prizes. So you can test your knowledge, deepen your knowledge of PL/SQL, and possibly even win some prizes. And my own StephenFeuerstein.com site with all sorts of fascinating information, I'm sure, but mainly you can put in your email address for Stay Connected and receive my monthly newsletter on Oracle PLSQL topics. So lots of resources out there for you, many more besides what I just showed you, but let's dive in and talk about the agenda for the Say Goodbye to Hardcoding series. First, I'm going to talk about what constitutes hardcoding. Then we'll take a look at why it's a problem. I'll talk about the opposite of hardcoding. Then we'll take a look at identifying where the hardcoding can appear in your code, because one of the biggest challenges I think we all have is even recognizing what all the different circumstances of hardcoding are. Then we'll look at specific techniques for getting rid of the many forms of hardcoding in the subsequent lessons in this series. So, what is hardcoding? Well, let's go to Wikipedia. So in Wikipedia, we find that the term hardcoding was coined back in 1990 by R. Galashon, and he used it, or she perhaps, used it as an analogy to hard wiring of circuits. It was meant to convey the inflexibility which results from usages within software design and implementation. So the first thing to recognize is that hardcoding is linked to inflexibility. And basically what it often refers to, and usually refers to in our minds, is placing literal values in the main body of your code. In other words, the maximum salary in my company is $1 million, so we'll just hardcode 1 million all over the place because that's never going to change. Well, we know that's not true, but we still do it. More generally, hardcoding is closely tied to the problem of repetition in our code. Generally speaking, if we hardcode, we end up repeating. Some more thoughts about hardcoding. My feeling is that you hardcode, you commit an act of hardcoding every time you write a piece of code that assumes an aspect of your application will not change. You're making an assumption that it's this way now, it will always be this way, and therefore it's safe to explicitly reference that value or that rule or whatever else throughout your code base. So it all has to do with making this extremely dangerous assumption of something not changing. Then, of course, when the change takes place, which is totally inevitable, you have to locate all those places where you put in that value or that rule, etc., and you have to fix them. Now, sometimes it's easy to do. You can even sometimes do a global search and replace in your files. Sometimes it's really difficult to do. For example, when you have a complex rule or an SQL statement. But in every single case, it causes problems. It can cause problems mainly for maintenance and evolution of your application. It can also sometimes cause problems regarding correctness of the application and performance. So, well, I guess I've kind of answered why is hardcoding bad. But hard coding would be fine, no problem. Do it all you want if nothing ever changed in our applications, if requirements stayed the same, if the definitions of our tables stayed the same, if our business rules and formulas stayed the same, if our constants for configuration elements of our application stayed the same, then fine. Make multiple copies, make multiple references to the specific value over and over again. Who cares? The problem is that everything is going to change in our application. Then we have to find all those places and explicitly code that I explicitly coded them and fix them. So that's the fundamental problem with hard coding, is that our applications are always in the process of changing, which is not really a bad thing. An application that doesn't change is pretty much a dead application. It's changing because the real world requirements change, the user needs change, and our applications must change along with them. So change is good, but we need to design our applications so that change doesn't trap us in an inflexible, brittle application that breaks easily. Well, if hard coding is bad, maybe we should look at the opposites of hard coding. So I'd say that the first kind of opposite of hard coding is soft coding. Rather than explicitly coding our values, our rules, our algorithms, etc., make them soft or dynamic, which means they're changeable and settable at runtime, or at least they're put in place, they're defined in one place so that they can be easily changed. But ideally, the best idea is that you never have to change your code. You might be able to go into a table and make some changes, and it would automatically have the desired effect. Another opposite of hard coding is easy coding, because the bottom line is that while in the short term it feels easier to take a shortcut and use the specific magic value or the hard-coded reference to a rule, over time, hard coding makes it really hard to maintain your application. So it's hard fixing multiple places of occurrences of a hard coding. It's a lot easier to fix things when they're defined in one place. So I think these two perspectives, these opposites of hard coding, can inform the way you think about how you're going to write your code. One is to make it as dynamic as possible. The other is to make it as easy as possible to maintain your application over time. Let's talk about some hard coding avoidance, basic principles and concepts before we dive into a lot of the specifics. First, this is a very critical one for me. Single point of definition, also known as a SPOD, known to me anyway. I believe this is my acronym, and I bestow it upon you to use as much as you want. Create a single point of definition for everything in your application. Therefore, if you need to change that definition, if you have to change the value or how the rule is defined, etc., you change it in one place, and everything else in your application references that one single point of definition, and they automatically are updated. A great example of that kind of feature built into PL/SQL and Oracle is the %type anchored declaration, which we'll certainly talk about. Information hiding. So this is a very common concept in the world of object orientation. You don't show everybody everything and how you're doing it. You hide the details behind your methods, behind your attributes of your type. And the key thing here, and information hiding is not specific to object orientation, but the key thing that's going on is that we're giving a name to something else. And this process of naming things is a fundamental aspect of abstraction, which I think is also very critical overall to sentience, to being a thinking human being. We would get lost in the overwhelming details of the world around us if we couldn't name something, if I couldn't say, that's a tree. And not only is that a specific kind of tree, but I've named a general category in which all those different trees fall together. And that abstraction process, that naming process, allows us to hide the details of this thing that is a tree. It's a very tall structure with this rough surface on the outside and these green things that flow around in the wind. No, we just say that's a tree. And the more that we can hide information and hide it behind a name, the more we avoid exposing the implementations, how we get things done, the more flexibility we have. Because if we don't show all the information, if we hide our implementations, then we can change those implementations. We can change the information without having to change all the places in which they're called. So this fundamental idea of replacing all the details with a name is critical to many aspects of software, and certainly just aspects of living as a human being. Finally, never and always in software. I don't know about you, but when I'm writing my code, I often have a little conversation, a dialogue running in my head while I'll be commenting on the code as I'm writing it. And often my silent commentary is not very complimentary towards what I'm doing. Stephen, why are you writing that? You made that same mistake last week. Don't do it again. And that's the good voice. The bad voice is when I rationalize things. So I'll be saying to myself as I'm writing my code, well, this is okay to do because this value is never going to change, or this table is always going to stay the same. And I suggest to you that you try to listen to the voice in your head as you're writing your code, and also listen to others talking around you. And if you ever hear the word never, then you should just laugh. It's a joke. You should automatically reject whatever anybody is saying. If they say the word never, unless it's in the sentence, it's never going to stay the same. If anybody ever says always when they're talking about their code, you should start laughing and say that's ridiculous, unless they're saying it's always going to change. But if it's not these two sentences, then the word never or always usually indicates somebody making an assumption that is a bad assumption and will result in problems further on down the road. So, aim for single points of definition, hide details behind a name, a procedure or a function call essentially, or a constant, and avoid never and always assumptions in your software. And finally, as I've mentioned, you'll often have this dialogue going in your head, talking about your software. Listen to that voice in your head. It doesn't mean you should always believe it. Sometimes it's telling you bad things like, you don't have time to do it the right way, Stephen. Take a shortcut. It's okay. So you have to be judicious about when you listen to the voice or not, but the voice is usually giving you some very important clues as to problems that you might be introducing into your code. Okay, let's finish up this first lesson by taking a look at a piece of code and trying to identify what all the hard codings might be. Now in my demo zip you can access the hard coding file, and you can look at this obviously in as much time as you want. In fact, what I suggest you do is pause the video before you look at my explanation of all these hard codings and see how many you can find. See how many things in this piece of code you feel represent a form of hard coding. So pause the video now, and now let's take a look at what I consider to be all the hard codings, or at least I think all the hard codings in this single block of code, and see how many you've discovered for yourself. First of all, we have lots of hard-coded declarations. My department ID is hard-coded as a number type. My LID is an integer. My salary is a number 9, 2. My list name, the name of my employee, is a varchar2 100. Those are all forms of hard coding, the worst I think being the varchar2 100. In fact, let's talk for a moment about why that might have happened. If I look at this code, what I'm doing is processing an employee, pass in a department ID, get some employee information for each employee in that department, and then process that employee. Now, just in terms of getting the information for the employee, I have to get the full name of an employee, and the documentation says it's last, first. Well, I need to drop that into a variable. Well, or maybe I don't, but assuming I'm going to create a local variable to hold this last name, first name. How do I decide what the size of that variable should be? Well, I can use %type to declare some of my variables, and we'll talk about %type later on in the series. But I can't use %type for last name, first name because it's a derived value. So what I'm likely to do is go to the employees table, look up the descriptions of these columns, 20 for first name, 25 for last name. That adds up to 45. I'm going to add one more to it for the comma. That means, well, I can easily make it varchar2 100, and that'll be more than big enough. It's never going to get to be that big. Whoa. Well, there's an example of one of those usages of the word never. I've made an assumption that's never going to get to be that big, and I've hard-coded that assumption inside my declaration. That, of course, will lead to problems if my column sizes ever expand. So that's an example of why these constrained and hard-coded data types are problematic, or hard codings. Next, line 6. I've put a box around a comment. How can a comment be a hard coding? Well, my comment is describing what the rule is for determining how to construct the last name, or I'm sorry, the full name of an employee, namely last, first. So I've taken the requirement, or the rule, I've hard-coded it in my comment, and I've hard-coded it in my select statement. So if my rule ever changes, I've got to change it in both places. I've got a box around department ID in, and that's because this is a form of really a global reference, which is another form of hard coding. My cursor does not have any parameters, which it certainly could do. And because of that, I directly reference my department ID inside the body of my cursor. Now I suggest that you can think about cursors as being just another kind of function. I pass in input values, basically my bind variables. I return a set of values from my select list. It's just like a function. And in general, inside your function bodies, you don't want to have direct references to elements declared outside of the scope of that function unless it's passed in as a parameter. By hard coding the reference to department ID in my cursor, every time I use this cursor, I have to have my department ID parameter set and in use. If I pass it in as a parameter, then I can use my cursor with different department IDs. So that's another form of hard coding. Lines 9 through 11, I've got a box around the SQL statement. I believe that every SQL statement you'll ever write is a hard coding in one of the worst kinds altogether. And I'll come back to that in my separate lesson on the topic. Moving down to the executable section, my fetch statement. My fetch statement in line 17 has a hard coding, which probably a lot of you didn't catch. And the hard coding here is that I've hard coded the number of elements I'm selecting. I've got 3 up here, and I'm assuming that there'll always be 3. But if I change my select statement, if I add another column to my select list, I have to change my fetch as well. That's a hard coding. Lines 19 and 20, obviously, and I'm sure a lot of you saw right away, I've got the reference to 1 million, hard-coded literal value, my magic value. That's a problem. I've also put a box around if salary is greater than 1 million, because that's a business rule, and I'm exposing that rule, and it should really be hidden away behind a function. Commit. I would argue that every time you issue a commit or rollback inside your programs, you're performing an act of hard coding. You're hard coding the transaction boundary. After this point, you can't go back. The changes are saved, and that's it. And you might say, well, that sounds kind of silly. Why else would you do a commit? And that's true. But sometimes the process of committing is more complicated than it would at first seem. And it's another example of where soft coding can give you some additional advantages. Finally, line 26, in my exception section, I've got 2 levels of hard coding. One is I've hard-coded the error number and the error message, which almost always happens when you're working with raise application error. And the other hard-coding is the use of raise application error altogether. I've hard-coded how I want to raise my error. And you might say, well, that's the way that Oracle gives us to raise our errors back to our users, our application-specific errors. And I would say, yes, that's true. But it doesn't mean you have to hard code the mechanism the way that you're going to be doing that raising. In fact, I would argue that all of that should be hidden away behind a single utility that handles all the details of logging and raising errors for you. Okay, so let's see, that's 26 lines of code and at least 15 different hard codings. Wow. And I would argue that you'll probably find even more in here. And in fact, if you look in your own code, you will find it littered with all sorts of hard codings, because hard codings are much more than hard-coded literal values. So let's just review the list, then we'll sum up. Potential areas of hard codings in PL/SQL code. Yes, definitely magic values, the literal values, the things that you think will never change, especially the language-specific ones. Constrained declarations. I will argue that every single var-car2 declaration that you perform in your code should be considered a bug, unless it's the single point of definition for that variable. But not just var-car2s, they're just the most egregious examples. Fetching into a list of variables instead of a record. Rules and formulas. Every time you're expressing a rule, a business rule and a formula, even and maybe especially the most trivial ones, that's a form of hard coding unless it's the single point of definition. SQL statements, as I mentioned, I consider every SQL statement you write to be a hard coding. And I'm sure that sounds rather scary to a lot of you, since you write SQL statements all over your applications. They're hard codings? We'll come back to that one. Algorithmic details, essentially how you're getting the job done. For example, how do you log errors to your error log table? How do you do exception handling? How do you implement various elements of your underlying architecture? The more you hide, the better off you are, and the more you expose, the more you're hard coding how you're doing those things. Transaction boundaries and dates. Remember I had mentioned that I think a commit and a rollback are examples of hard coding, and even a reference to sysdate should be construed as a hard coding. You're assuming that you'll always want to reference today's date directly by calling sysdate. So lots and lots of possible hard codings. This can be rather intimidating for developers because there's so much to keep track of. But the main thing is to first of all recognize that you've got these potential hard codings. So lots of different ways that hard coding can creep into your applications. The first step to avoiding your hard coding is to understand their negative impact, why it's problematic, why if you hard code, you repeat, why if you repeat, you'll have a hard time maintaining your applications, and they'll be brittle and break easily over time. The next step is to broaden your understanding of what constitutes hard coding. It's not just a matter of those literal values. There's so much more at play, so much more at issue when it comes to hard coding. And in fact, the literal values are misleading because they're the easiest form of hard coding to address and resolve and avoid. But the next and most specific thing is to learn the specific techniques for removing the hard codings, and that's what the rest of the series on stop hard coding in your applications will do for you. So if you haven't already done so, download the demo zip file from PL/SQL Obsession, take a look at the hard coding script, see if you can identify all the hard codings in it, see if you can identify more hard codings, and if you ever see a problem with my presentation, or you discover that I've missed something, then just go to PL/SQL Obsession, click on send me an email, and you can send me a note telling me what you think of the videos or something that you think I should add to them. And then drill down into the specific lessons for eradicating the various types of hard coding, literal values, SQL statements, and so on. I hope this initial lesson on hard coding, overall concepts, understanding the different forms of hard coding that it can appear, has been helpful to you, as will be the rest of the series. Happy PL/SQL coding!